All right, let's talk about one of my favorite design patterns, the Memento Pattern. Now, you've probably never heard its name, but I promise you, you use its most famous trick all the time. I'm talking about the undo button.
You know that feeling, right? You spill your coffee, you say exactly the wrong thing in a conversation, and you just wish you could hit a cosmic Control plus Z and take it all back. That impulse to just undo a mistake, it's completely universal. Well, in the digital world, that power isn't some kind of magic. It's actually the result of some really clever engineering, specifically a design pattern called Memento. So how does it pull off this kind of digital time travel? Let's dive in. We press that undo arrow or hit Control plus Z 100 times a day without even thinking about it. It feels so natural, so simple. But believe me, behind that simple button is a surprisingly tricky problem for programmers to solve. This pattern is the silent hero behind so many things we take for granted. You know, deleting a line of text and bringing it back? That's Memento. Reverting a change you made in a design program? That's Memento too. Even loading a checkpoint in a video game or rolling back a database transaction that went wrong, it all comes down to the same core idea: saving a state so you can return to it later. So what makes this so hard? I mean, why can't you just save everything all the time? Well, it turns out it creates a huge conflict with one of the most important principles of good software design. And here's the core of the problem. How in the world do you take a perfect snapshot of an object's internal data while at the same time following a golden rule of software design that says you should never be looking at that internal data to begin with? That rule has a name, and it's called encapsulation. So, encapsulation, think of it like a protective shield around an object. It's a fundamental principle. It means an object's internal guts should be hidden away from the rest of the world. You're supposed to interact with it through a nice, clean public interface, not just reach inside and mess with its private data. This is what keeps code strong and easy to maintain. And this puts programmers in a real bind. It gives them two equally bad options. On one hand, you could just expose everything, let other parts of the program see the object's internal state so they can save it. But that shatters encapsulation and makes your code incredibly fragile. On the other hand, you could hide everything, which is the right way to do it, but then how does anything outside that object save its state? It's impossible. You're stuck. So, how do we get out of this trap? Well, this is where the Memento pattern makes its grand entrance. It's a truly elegant solution to this fragile versus impossible dilemma. The official definition really says it all. It lets you save and restore an object's state, but, and this is the genius part, it does it without violating encapsulation. It finds a clever way to let the object itself handle its own snapshot. The way the Memento pattern pulls this off is by using a team of 3 distinct components. Each one has a very specific job to do, and they have to work together perfectly. To make this really easy to understand, let's use a little analogy. Let's imagine an artist who's working on a masterpiece, and a museum curator whose job is to keep a record of the painting's progress. First up, we have the originator. This is the object that has the important state we want to save. In our analogy, this is the painting itself. The originator is the only one that truly understands its own internal complexity, so it's the one responsible for creating the snapshot. Next, we have the memento. This is the snapshot itself. Think of it like a photograph of the painting taken at a very specific moment in time. And here's the really clever bit. This photograph is opaque. No one else can see inside it or edit it. It's a sealed, tamper-proof record of the painting's state. And finally, there's the caretaker. This is our museum curator. The curator's job is super simple. Just take the photograph, the memento, and store it somewhere, safe. The curator doesn't know anything about painting, can't change the photo. They just hold on to it, maybe keeping a whole stack of them to show the painting's history. Okay, so here's what that looks like in a more technical diagram. Now, don't get hung up on all the boxes and arrows. The big idea is exactly what we just talked about with the artist and curator. The originator, the painting, is the only one with full access to what's inside the memento. The caretaker, our curator, holds the memento, but to them, it's just a black box. They can't peek inside. This strict separation of duties is the secret sauce that keeps encapsulation safe. So let's walk through the whole undo process step by step. First, right before you're about to make a change, the caretaker asks the originator for a snapshot. The originator then creates a memento of its current state and hands it over. The caretaker takes that memento and stores it away, usually in a history list. Then you go ahead and make your change. Uh-oh, made a mistake? No problem. When you hit undo, the caretaker just grabs the last memento it saved and gives it back to the originator. The originator then uses that snapshot to restore itself to exactly how it was before. It's so clean and effective.
But of course, as with anything in engineering, there are always trade-offs. No design pattern is a silver bullet, and giving your app a perfect memory definitely comes at a price.
And the biggest, most obvious cost is memory. I mean, it makes sense, right? Every single time you save a state, you're creating a brand new object. If that object state is really big, or if you're saving new states very, very often, you can watch your application's memory usage just skyrocket. So yeah, this is definitely not a free lunch. Beyond just using up a lot of RAM, the actual process of creating that snapshot can sometimes be slow. The caretaker also has to be really smart about cleaning up old, unneeded mementos to avoid memory leaks. And things can get really complicated if you're trying to save the state of many interconnected objects, or, and this is a big one, if the state itself contains sensitive information.
But even with those costs, the Memento pattern is an incredibly powerful and useful tool. So the next time you're in your favorite app and you effortlessly undo a mistake, you'll know the secret. It's not magic, it's just the elegant teamwork of an originator, a memento, and a caretaker working perfectly behind the scenes. When you think about it, the Memento pattern gives our digital world a memory. It's an elegant translation of a very human desire, the desire to go back in time, into clean, robust code. It really makes you wonder, right? What other real-world concepts are being solved by these elegant patterns in the software we use every single day? It's a pretty cool thought. Thanks so much for joining me for this explainer.